this is the 2015 AIME 2 problem 12. There are 1,024 sequences of 10 letters where each letter is either A or B. Find the number of strings that do not have more than 3 adjacent letters that are identical. So this problem is actually very misplaced. It's actually not that hard, and it's definitely not hard enough to be an AIME problem number 12. So the first thing we see when we see this adjacent letters thing is recursions. So I'm going to just visualize it right here. Alright, so as you can see, there's 10 letters here. So I'm going to let the number of sequences that are possible, I'm going to let this equal f of 10. Because there are 10 spaces here, I'm going to call it f of 10. So f of n is going to be the amount of sequences in a given space. So let me write it. F of n is the number of sequences in an n length string. Alright, so f of n is the number of sequences in an n length string. So now we have to figure out what this f of 10 is. So note that the beginning over here can only equal A or B. There's only 2 possibilities. So I'm going to let A of n equal the number of strings that are length n that start with A. And now B of n is the same, except it starts with B. Alright, so now that we have these two, we can set a little equation here. So we know that since it either has to start with an A or a B, f of n must equal A of n plus B of n. So we can see that these two are equal. A of n and B of n are equal because they have the same amount of possibilities because they're symmetrical cases. So now we proceed to find out what A of n is. So this is A of 10 right here. So A of 10 right here. So how many ways can the sequence progress? So first of all, we just have when this is equal to B. So this would be B of 9. Now, we also have the case where this is an A, this is B, so we have B of 8 here. And then we have the triple A's, and since there can only be 3 adjacent maximum, we have B is here. So this is B is 7. Now, as you can see, this is the case where there's A, but the case with B in front is the exact same because these two cases are symmetrical. So we have A of n, I'm going to generalize this for n because it's very useful, is equal to B of n minus 1 plus B of n minus 2 plus B of n minus 3. Now we have B of n is equal to A n minus 1 plus A n minus 2 plus A n minus 3. If we add these two together, we get that since A of n plus B of n is equal to f of n, we have f of n is equal to f of n minus 1 plus f of n minus 2 plus f of n minus 3. So here is our recursion. So now all we have to do is have a base case, and then we can go on to solve the problem. So I'm just going to calculate f of 1, 2, and 3 first. So f of 1, there's only one case, A or B. This is equal to 2. F of 2, 4 cases, and f of 3 is equal to 8 cases. And now we can proceed with the recursion. 2 plus 4 plus 8 is equal to 14. F of 5 is equal to 4 plus 8 plus 14, which is equal to 26. F of 6 is equal to 14 plus 26 plus 8 is equal to 48. F of 7, F of 8, F of 9, and F of 10. So we just continue calculating here. 14 plus 26 is 40, so this would be 88. This is 132 plus 26 is, this will be 162. And these two added together is 250, so this is 298. These two added together is 460. So add 88 here and you get the final answer of 548. And our problem is completed.